Hey guys. So does everyone know Comic Relief in general? So Comic Relief has raised about £1 billion. So it's been running for 25 years or so, alternates between Red Nose Day and Sport Relief, and culminates in a massive telethon on primetime BBC TV every March or so. And once a year, it raises 90% of its public donations in a several-hour window with no opportunity to do it again. There is zero annual feedback, apart from one night a year, at which point it takes 90% of its money. And this is a challenge. So Comic Relief need help. They need help because A, they've got a tiny budget. So what they're trying to achieve is a globally distributed financial platform that is going to take 8 figures worth of pounds, and they're going to have no second chance. So everyone's going to donate on the night, and if we can't take that money the next day when we say, we should have taken that money, can you do that again? Because they're going to say, not really. I'm doing something else now. It's Monday morning. I've got my job to do. I'm not doing that. So, and there's no operational feedback. So the platform does not run in the year. We can pretend to simulate it as much as we like, but in terms of real users with their fingers and wrong credit card numbers and bank accounts with no money in it, all that sort of stuff is quite hard to replicate. And we don't really get to do that in the year. And the whole thing operates at significant scale. And I guess maybe the most important thing is brand confidence down here. So Comic Relief basically is its brand. Its main asset is Comic Relief and what it means to people. So if, for example, Comic Relief was to try and take the money and it couldn't do it for, say, like a security problem, or it took everyone's money 14 times and no one could, pay their bills on Monday morning and all those sorts of things, that could spell, in the worst possible case, I guess, the end for Comic Relief. Comic Relief would cease to raise the £1 million, £100 million that it does every year. People will die, people will not be supported, charities that depend on Comic Relief for funds would close down. Yes, that's some sense of the Comic Relief scale. Mine's been Dodd. Just reiterating. Okay, so what are the requirements? So the requirements is that there is a 10-week campaign. So this is across all the media, print, TV. Currently you'll see it for Sport Relief. So Joe Brand is running them down. Eddie Izzard's about to go to South Africa, I think, and do some running around too. So you arrive at this point about 9, 10 o'clock on what is generally like the 18th of March or so. At this point, Tenet is put on TV, generally with some heartbreaking story. And the whole organisation, the whole country is drunk, and it's drunk on booze and also drunk on just the emotional side of, I really want to help. I've seen this story, it's built up in my subconscious, now it's in my primary thought. It's time to donate some money. So we get to this point. So at this point, 100,000 or so concurrent web donors, pretty much at the same time, get their laptops out and think, I'm going to donate some money. And on top of that, there's 14,000 or so call center operators. So these are big sort of telcos and things that donate their call centers for the night. And there's 14,000 of those all logged onto our platform too, all taking money from people who call up instead of wanting to donate online. And this is what you end up with. So there is sort of, and this could extend infinitely into the year in either direction. But you get this spike, and this spike is 10,000 donations a minute, or about sort of 200, 250 donations a second. And this is really what we spend our whole year engineering for this window here that is probably only about 25 minutes wide. So yeah. And 1 second, not checking my emails, I promise. So we agree these key performance metrics with Comic Relief. So we say our platform will take 400 donations a second. Generally, it probably hovers around the 150 mark. but that's dependent. There's a sort of plethora of other platforms. So there's automated donations via IVR and telephone, and there's a PayPal system and these sorts of things. So should all these platforms go down, conceivably 400 donations a second could arrive at our platform. And to give that some context, so all of the card transactions that are going on in the country, every single one in every shop, in every bank and all that sort of stuff is 400 donations a second. So at that point, we are taking the equivalent of every possible way of paying by card in the entire country. Another example, for example, too many examples. So when Glastonbury sells out, so when they sell 150,000 tickets in the hour or so that they do, they are doing 40 or 50 card payments a second. So sort of 8 Glastonburys or so, or equivalent of every payment in the entire country. So in terms of our solution, and specifically, I guess, in terms of Cloud Foundry, so we have an instance of our applications, and it's 28 or so applications or microservices, and we deploy them in a single Cloud Foundry. And this Cloud Foundry was provisioned by Bosch. It's in EC2 in US East, and this Cloud Foundry could take 400 donations a second. So we know that this platform, which has been load tested, can do everything that we need it to do. And then for resiliency, we had 2 more. So we had another one in EU West, and we also, via Bosch, deploy this exact same Cloud Foundry to a VMware. So then we've got the whole platform with 3 levels of redundancy deployed over multiple regions and across 2 infrastructure providers. And in terms of the critical part of actually taking payments, we load balance across at least 3 payment providers. So we're doing this sync and async. So ideally, we want to do everything synchronously. So we want to take the money, check their account, and then confirm that we've got the money. And if we haven't, which is what happens in probably 15% of occasions because people are drunk for various reasons, we like to say, that didn't work, please donate again, give it a go. But then also, if one of these payment providers fail, they will seamlessly move from that payment provider to another payment provider. So they'll just go, oh, oops, that didn't work, please just do your details again. And then they'll automatically switch to one of these. So this is sort of a minimum time to recovery model as opposed to a high availability model, which we would have operated with previously, where we'd just had one payment provider, and if that didn't work, yeah, it didn't work. See you on Monday. Yeah. So added to that, we pop in another Cloud Foundry for good measure, and that one does all our insights. So that's where Comic Relief can go and get donation totals and all those sorts of things, and then all the monitoring is being streamed out to centralized logging, metric servers and alerting, and all the data flows instantly out of our platform into Comic Relief's databases, so that this platform essentially gets turned off at the end of the night. There's no data left in the platform, so to reduce exposure for having this sort of platform live, we just shoot it at the end of the night, knowing that Comic Relief have got all the money, the banks have, Comic Relief have got all their data for gift aid, and then the banks have all got all their money. That didn't make sense. Okay, so a little bit on how the actual platform works and how we can load balance across those multiple Cloud Foundries. So all the transactions are event sourced. So we have, for a single donation, we have these multiple deltas, we call them. So at any point, people will fill in their card details, and they'll go to one Cloud Foundry. So they might go to EU West, fill out that bit, and then they'll, so the bit before that, probably they'll fill in their personal details in one, then they'll fill in their credit card details, they'll get their summary from somewhere else, and all those create a delta, a part of a transaction, and then that then flows from each of the edge Cloud Foundries to the inside Cloud Foundry, and those are, at that point, that whole donation is put back together in the right order. If anything, actions need applying to that transaction, emails need sending, anything like that, that all happens at that point. And this is all because there was a realization with the Comic Relief platform that availability was much more important than consistency. So it was important that Comic Relief could take all the money, but it was not important that they could see all of their data. They didn't need to see it in real time, all aggregated in one database instantly. It was most important that we just got to that point where we'd taken the money. And taking the money for us is their details, their card details, and then at any point later we can take the money actually from their bank accounts, but we know we're at that point where we don't need the user anymore. And it also leaves us in this situation where we can lose huge swathes of our platform and still take all the money. So in this situation, we're losing most of our payment providers, we've lost nearly all of our shards, we've lost our insight layer, but we still know that with that one remaining shard, that we can take 400 donations a second. Yes, there you go. Yes. Okay, cool. So one of the key engineering principles that we have is that absolutely everything goes through our CI server. So we have a concourse server, and that delivers everything. So it's not only delivering all of our apps to all of our shards, it's also delivering all of our platforms. So all of our Cloud Foundry code, all our monitoring, DNS, all that sort of stuff is all done by our CI server. At no point do we manually configure, type in, log in, do anything. Everything goes through this pipeline. So every change we make can go through here. Comic Relief can know that they can maintain the level of confidence they've got, because not only have we done unit integration, we've done feature tests, we're also doing security tests, and we're doing load tests. So every change to anything goes through that entire process, and we are continuously delivering the whole thing to production all the time, to the point where we will do this on the night. So last year, there was a minor change that we had to make. The platform was doing 50 donations a second or so, and we did a 0 downtime deployment to production, the change having gone through this whole pipeline. Yeah, so load testing is incredibly important. So we, are load testing us, so we spend a huge amount of time doing that. We also have to load test all of our payment providers. Lots of payment providers have very good marketing departments, and marketing departments say that they can do almost anything. This is really true. So we spend a lot of time proving marketing departments right or wrong. And we do this for technical interest via a grinder platform that we have a Bosch release for. So we get to the point where we can deploy a change, scale up an entire platform to do 100,000 concurrent user tests, and scale that whole thing down and have meaningful results within an hour and a half or two. Yeah, it's kind of useful. So in terms of specifically how Cloud Foundry has helped us, it's given us the Cloud Foundry contract. And this is a contract we started with on day one. So we've probably been doing this for 3 years or so. And on the first day, we were given this project. Within 3 days, we were back in front of the board. We had a working example of a proof of concept of how the platform might work. And that was on the Cloud Foundry of the day, the pivotal Cloud Foundry. And that contract really hasn't changed for us in 4 years. The paradigms and the concepts, and really even the tooling hasn't changed for us in that entire time, which has meant, the Colin talking about we are stopping for 6 months to do the platforms. We didn't do that. We stopped for 15 minutes, created an account on a public Cloud Foundry, and then we're building code, proof of concepts, talking about event streaming and all this sort of stuff, and not worrying about platforms. Yeah, I imagine most of you know how to do CF pushing. This is very much meant for a different audience. So all of our apps are built as 12-factor apps, and this has meant that we can horizontally scale. So this is incredibly important for us from getting between assist tests, where we just want to have one app instance, we want to test it, and then we go to probably 300 or 400 instances of the presentation and the service layer apps to get us to that 400 donations a second. But it also means that for Comic Relief, we can scale down. So we are currently deploying to Bluemix, and that means at the end of every day, we will turn the platforms off, we'll turn them off at the weekends, and that means 70% less cost, which is an important thing for Comic Relief. It also means that pipelines are very easy. So So it means, for example, like currently we need to do pen testing, so we need to scale up other platforms. We need to do another, whole pipeline to deliver that platform. That means that's generally sort of 15, 20 minutes work, as opposed to we need a specific platform for pen testing. Give me a week, we'll see what we can do. And it also means we stop having to worry about things like deployment consistency, deployment downtime. All those sorts of things we just get for free. We just don't have to worry about those. And it's amazing talking to people that don't have this sort of tool set, how much time they spend thinking about downtime and deployments. I was talking to someone at a big charity the other week, and they had a deployment week. And they're a charity with like 2,000 employees or so, and they're having deployment weeks to get their stuff out. It's just something you don't have to worry about. Resourcing is quite interesting for this. So the stat that a lot of people are quite excited about is to deliver the platform before we had it, which actually Colin was, a part of, it took about 50 people. So we had like a huge HP, Laurie would turn up to our data center, we'd have to plug all that in, that whole thing about configuring. We had a massive Oracle stack, so we needed like a team of 10 people came from Oracle, mostly carrying licenses. We had a Cisco department, they were on site, all this sort of stuff. And we generally changed that from that team of 50 or so to 5. So we build this whole platform with probably 5 people. That's a huge difference for Comic Relief. And also portability. So this is our general platform that we build out for Comic Relief. So we have this sense that I illustrated before, a couple of AWSs, a VMware. But Comic Relief don't want to own that, so they don't want to own that. They don't want to own the tooling that provides all that sort of stuff. They don't want to pay us, to provision these massive Cloud Foundries. So the point we can get to now is where we run for the majority of the year, and increasingly looking towards like a production night on provided Cloud Foundries. So we run currently on Bluemix. We're using SwiftCom too, and that for Comic Relief is good. Because Comic Relief aren't experts in distributed computing, they just don't want to have to do that. And they're forced to do that because they've got this unique, large requirement. What they actually want to do is concentrate on campaigning and coming up with incredible media reasons why you should donate, not then to have to worry about provisioning thousands of VMs and things. So it means at that point they stop having to worry about that. And I think also, I don't know, there's lots to talk about what Agile means and what DevOps means. I think for us, it gets us very close to what Agile is. So in terms of feedback, we're down to sort of an hour. So if you've got an idea in the morning, you're sitting in a meeting, you've got an idea, we want to try this out. It means you can have that idea, you can develop it, you can deploy it because you've got the confidence with the pipeline to get it through. But then also you can have it into production and be getting feedback. I think that's incredibly valuable. And I think also, like we don't do this incredibly much. We haven't had much opportunity to re-architect, but you can do. Re-architecting, coming up with a new proof of concept isn't, provisioning massive new servers. Oh, I want to try this out in Node, or we want to switch this to Go. It's all in Ruby. Ruby's not very cool this week. Let's try this in Go. And for us, that would just be, a new runtime, and that's incredibly important. So could you trust Cloud Foundry to save a life? Could you trust it to save 10,000? I think Comic Relief is trusted with a lot of people's money to do good, and they certainly do that. I think Comic Relief, in turn, trusts the platforms that we provide, and they trust them not through blind faith, not because we say it's HA. They trust them because they see them working every single day, and they trust them because they see every single change that they make demonstrated to them on a daily basis, and it gets as close as possible to what the event night can be on a daily basis instead of being on a yearly basis. So yeah, I don't know if we're doing questions, but I put questions. Go on then.
What did they do 5 years ago or 25 years ago?
How do you mean?
Without all this technology, they clearly took large numbers of donations 25 years ago.
Yeah.
Presumably without many computers.
Repeat the question.
So the question is, what did they do before us? They had to take large amounts of money. How did they do that? So they did have to take large amounts of money, probably not quite as much. And the brutal answer is that they probably didn't. So we were all involved in this project before then. So Colin was also involved, fingering Colin in this one. So we did the best we can. Like there was a massive Java stack. It was out the banking people. There was huge amounts of resource in terms of servers and all that sort of stuff. But there was just infinite amounts of configuration, manual, and regularly it would go down. We had good people, I think, working on this, manually configuring stuff, and it would just go down. You just couldn't concentrate on it hard enough to keep it in line, stop the network guys just, I wonder what this does. Just click that. I'm a Cisco guy. Yeah, we're doing, So I think the solution was, good and could take lots of money and had lots of performance and all that sort of stuff. The problem is they just didn't have the automation. They didn't have the consistency. They had just incredibly reliant on humans. And what we've done is the exact opposite of that. It's not reliant on humans. We develop the stuff, but there's nothing that humans do in terms of deploying these platforms and getting them working and tested. That's all automated.
Firstly, I would say it's the second time I've seen this talk and I really love it. I would like to make everyone that I talk to about automation see this and see what's possible. So thanks for giving it to us again. Are you planning on giving a more technical version of the talk at some point in the future? It would be really interesting to see at a more kind of algorithmic and code level how you got things to work. For instance, in the slide where you were showing various bits of stack on fire, how did you say the Insight Cloud Foundry went down? How were hanging transactions from the one remaining Cloud Foundry that was receiving traffic from donators? How were those transactions pushed back down? Was that done off the facts with some kind of manual process of go and sweep these up, or were there threads spawning going, do we have any unreconciled transactions here?
Okay, so to repeat that question, the first part of that question was that, we're awesome. The second part was when shit goes wrong, how do you deal with that? So in terms of so if the front end shards go, the first thing we would do is change the DNS. So that is automated. We would change the DNS so that majority of people weren't going to those shards anymore. But then also we'd engage what we call failure wagons, created by Jonathan, who's over there, and they would redirect anyone else. So anyone sort of in DNS lag land would hit a server and be redirected to a known good shard. And if we lose the Insight shard, because of the model of event sourcing, it doesn't matter. So what we would do is build a new Insight shard somewhere else, point all those shards at it, and just hit all those queues in replay mode. So we'd ask all those shards to just resend all their data down to the Insight layer, at which point it all gets pieced back together again. And then also, one of the key parts of everything being synchronous is that we've already got the money. So that's all in the various banks. So Comic Relief loses its ability to report on it, for example, but the money is in the banks. They can get the money, which is the most important part.
If Cloud Foundry didn't exist, what do you imagine would be the closest thing that you would use to do the same, to achieve something?
I don't know. I struggle to imagine that. Sometimes you do sit and think how we used to do that. I've written deployment servers like lots of people and had to worry about consistency of servers and scaling up and all that sort of stuff. There's certainly other, sorry. The question was, if it wasn't Cloud Foundry, what else could you use? There's certainly other PaaSes on the market. And we certainly, as part of our original model, where we're having multiple infrastructure providers, we also had multiple PaaSes. And at the time, sort of 4 years ago, the other large-ish PaaS that was available wasn't really usable. It sort of just didn't meet the requirements of scaling and reliability and all those sorts of things. So in terms of what else is on the market, what we'd switch to if Cloud Foundry didn't exist today, to be honest, I don't know. I can't imagine it is probably the answer. Yep.
What's the biggest problem you have with your current setup?
So the question was, what was the biggest problem we have with our current setup? Almost certainly the payment providers, probably, because payment providers don't like to be tested. And it's also quite hard to replicate that whole process. So, international cards, cards that run out of money and all that sort of stuff. People, humans doing things wrong at a very large scale. It was just probably all the payment provider stuff, like the Cloud Foundry, the architecture, took some time and all those sorts of things, but was never really the huge problem. Payment providers, I guess, external dependencies. Thank you.